All right, welcome everybody to the West Virginia Watershed Network's webinar series, the Nonpoint Source Program Approaches to Reducing Fecal Coliform Pollution. This is the fourth, February 29th, fourth of 5 weekly webinars that is providing tools and information to help watershed organizations reduce non-point source fecal coliform loads in streams. My name is Jenna Dotson. I'm the staff scientist at West Virginia Rivers Coalition, and I also help coordinate the West Virginia Watershed Network. If you haven't heard of the network before, it is a network comprised of nonprofits as well as state and federal agencies who support the work of watershed organizations across the state of West Virginia by providing resources and opportunities for collaboration, training opportunities like this one, and much more. So we're really happy that you all are here today joining us for our fecal coliform webinar series. And before we get started, just a couple housekeeping items. So we are using Zoom webinar today. So if you are a participant, your video and your audio are off. And we are recording the webinar too, as you saw. So we're going to be posting the recording on the Watershed Network website, as well as sending it out with the relevant resources to registrants afterwards. Our recordings for our 3 previous webinars are already posted on the Watershed Network website. So Martin's going to put that link in the chat, and you'll want to scroll down that webpage, and they're listed under webinar recordings if you wanted to see any of the other webinars so far. And then for questions, you can type any questions that you have in the Q&A box. It is on the bottom of your Zoom toolbar, and you can add your questions to the Q&A box anytime throughout today's session. Alternatively, if you would prefer to ask your question out loud, you can also indicate that in the Q&A box and we can unmute you so you can ask your question out loud. We're going to have 2 speakers today, so 2 presentations, and there's going to be a Q&A session after each presentation. So with that being said, I will pass it over to Martin to introduce today's speakers.
Hi, I'm Martin Chris. I work for the West Virginia Department of Environmental Protection. I'm in the Watershed Improvement Branch, and I work with watershed groups in the northern part of the state. Our first talk is by Rick Hertges. He is a Health and Human Resources Program Manager for the Bureau of Public Health. He may be able to straighten us out about which part of DHHR that wound up in. I heard Rick give a talk back in the uh-ohs, when the year started with 200, and I am excited to have another round at learning from him. His working presentation title is What to Do When You Can't Put in a Septic Leach Field, but I'm hoping he will take off from there. So that's it. Go ahead, Rick.
Okay, thank you, Martin. Figure out how to get my advance button working here. Need a little help, folks. We're stuck in neutral. There we go. Don't know what changed, but so as Martin said, what are we going to do when a regular septic tank system is not going to do the job? As always, I have way too much stuff here and probably some basic stuff that most everybody in the audience is already familiar with. But one thing that I think I learned in the years of teaching this stuff is repetition is good, and basics generally need to be reinforced. So you're probably going to see some things that you're going to be scratching your head why I'm even bringing it up. But I'm going to talk a little bit about alternative systems, which we would automatically look at if a standard septic tank system is not going to do the job. And then the individual lot surface discharge, we'll talk about that a little bit, and then we'll try to get a little deeper into the cluster concept, which, you know, West Virginia's got a lot of neighborhoods where there's not just a lot with a problem, but there's a bunch of lots that were all created about the same time and share the same limitations, and thus they're begging to be tied together and something bigger done there. So going to start off a little bit with the decentralized concept after I get through showing you who I am. And I'm actually going to have a little more of that here in a minute. There's my contact info, and I don't think I got it back in at the end of the presentation. So email is my favorite, much better than the phone. I have this conversation all the time that the spoken word can be twisted, but the emails go on forever. Got about 5 slides here that are EPA slides from back in the day when decentralized was a strange word. It comes off of central sewer was the alternative. Historically, we're either going to do on-site or individual lot or on-lot systems, as they say in other jurisdictions, but decentralized, recognizing the fact that these smaller systems are legitimate and so oftentimes even superior to the larger, certainly the large pipe collection system. That all originated with the so-called response to Congress, as it was referred to. The legislators realized that, all the money that we spent on infrastructure, water and sewer both in the 70s was gone, and expanding further was costing too much money. So they went to the EPA and said, what's an alternative here? So they started looking seriously at the sustainability of smaller installations. Whoops, I didn't mean to do that. Decentralized system, an on-site or cluster system. So that's the first thing to understand. Is if we embrace the whole concept, it's also going to include individual on-site systems. And then mixing those together is not a bad thing, which is another paradigm shift we need to really get into this wholesale. Management and O&M was a big part of the consensus at the end of the study. And these studies continued and continue today as far as the best way to do things. But I think the big bang was back about 1997. I may have the date here in a moment. But basically they're recognizing the fact that on-site systems and other intermediate size systems are legitimate and can be expected to work properly and for the long term, properly managed, as we always have to throw in there. So looking at it kind of in a quickie little graphic, and again, this is EPA stuff. On the left-hand side, you see the concept originally was we'll put, and of course, we started out with treatment plants near the big cities, of course. They were generally sitting on a river somewhere. So they had a reasonable discharge point. Hopefully the water intake was upstream. And you see that every little dot there on the left is connected to the big sewer plant. I did make the plant a little bigger because EPA had both plants left and right about the same size. Go down here to the lower right and you see we got a little baby treatment plant out here for a cluster. And then we've got a larger cluster. You may consider that perhaps the town square central system. And then out here in the periphery, we've got all these individual systems that aren't, or individual structures that aren't connected to anything. And those would be on-site systems per the graphic here. So that's the understanding we need, is that we're looking at anything and everything. And we'll go ahead and explain what we mean by on-site. basically we're going to use the soil on the lot to treat the wastewater, or perhaps there may be some pre-treatment involved. Even the lowly septic tank is a pre-treatment unit and is considered primary treatment in the big picture of wastewater treatment. And then a cluster, the blue part, again, this is a couple bullets from the EPA, but I threw in the blue part here because it says cluster system, 2 or more dwellings, but less than an entire community. And I don't think today we would look at it that way, because communities is exactly what we're looking to pull together on a cluster design. Unless by community they meant larger towns, and even, there's no specific breakpoint for what might be a cluster design and what might be a full-on big pipe central sewer system. But oftentimes they'll use 1 million gallons a day, which is a pretty good sized system in West Virginia, as a break point between a true cluster and a central system. And as it says there at the end, on-site and cluster commonly used in combination. And today that goes without saying. This is old stuff here. This is going back to when this was still new, but it's still new to a lot of us. So again, I don't hesitate to go back and repeat things that you may have already seen. Oh, this is something that didn't take off. They say decentralized wastewater, also referred to as distributed wastewater. I think it might be a better definition, or a better term, I should say, but it didn't seem to get any traction. So decentralized is still the more common term, at least from my understanding. But it is what it says. We're going to put the treatment, and I haven't emphasized that enough yet. The decentralized concept would put treatment closer to where it's wastewater is being generated, and not expect to send conventional sewer for long distances where there's very sparse populations. Through those areas of sparse population, let's look more at either on-site or small cluster designs. Of course, again, the big thing is the collection system. If you can read that, my screen is partially covered, but up at the top, and I have it in here somewhere else too, that the collection system generally can be considered to cost about 2/3 of the overall cost of new wastewater infrastructure. So if we can cut down on the cost for collection, we can get the most bang for the buck there versus the treatment plant. And hence, let's keep the treatment plant smaller and closer to where the wastewater is being generated. Another couple bullets, just reiterating those facts. And 2 more, same thing. And a little of my personal history here. Been around way too long at this point, but I started out as a sanitarian in a single sanitarian county. So I did food, water, sewage, the whole thing. Then I took off to make my fortune as a independent operator, and I did perk tests and soils work and tried to get a little bigger, and did some design and operation of cluster size systems. Then I got sucked back into the health department racket somehow, and spent 3 years in the Berkeley County office up there, with multiple sanitarians underneath me, all of us doing nothing but sewage and some water well stuff. It was the busiest time ever, back 03, 04, when construction was going crazy and we had our work cut out for us. And then after I got run out of there, I've been down here for 19 years or so. And of course, that's back in the best days. So what do we do? Part of what Martin suggested was that we have generate some familiarity with what the state does versus what the counties do. And a lot of it overlaps. So this slide originally was what do I do, but this also would take in, I'm going to show you in a moment, a state map that shows where our district people are. And they're involved in these things as well as particularly some of the training and rule interpretation and that kind of stuff. But we're interpreting the regulations for the local folks in the county health departments. We're doing training when they're brand new, and then we're trying to do some recurrent training, in-service training meetings and such. Certified installers, some of those can do home study and take a test, but we offer courses semi-annually, I guess is probably the most typical. We have one coming up here in a month or so for installer certification. It'll last for a week up at the training center in Cedar Lakes. Troubleshooting, that's a big thing when there's a big problem. And, you know, particularly if there's personalities involved, we sometimes get drug in the middle of that and have to help sort things out. We do permitting out of the central office here for surface discharging systems, the small ones. Of course, across the hall, and I'll mention Bill Harold and the engineering group over here in a minute, I think, but they do everything else. So the larger surface discharges and some of the larger mass drain fields, so to speak, larger drain fields, they'll do those permits as well. And then when there's an on-site system that is larger, as I just mentioned, I'll work with the engineers since that's not their specialty, and we'll go through those plans together quite a bit. And there's Bill. He's the only guy down here I think's been here longer than I have. So there's our district offices. Those are actually going to change sometime soon. We got a couple new people coming on, and so these are now going to be regions. And I won't begin to try to explain how that's going to change, but there will be a couple other people over here in this right-hand column, and we've had pretty good rotation of folks there in recent years already, and that's going to continue, it looks like. And of course, the county offices, we have what's referred to as an A6 directory. If anybody needs to figure out who's in the county offices, you can actually search that out online. If you just go to Google and punch in West Virginia County Health Department's A6, A-6, you'll find one of those. Sanitary training, this was one of our larger groups that we got together because this was a semi-annual state meeting that we had down in Glade Springs. So we put a LPP, which is what I consider our most the most adaptable alternative technology that we have, and also it's affordable if you can find an installer that'll do it for the proper price. This is a very good system, small diameter pipe with hand drilled holes and pumped or pressure dosing. I'm sorry. So we just built one of those on top of the ground and made sure everybody understood the simplicity of it, pumping water out of the lake there. And then when we do installer training a couple times a year as well, we also have one of those coming up in a little over a month. This was up when we used to do it up at the West Fecal building at Chestnut Ridge. And we're doing one of my favorite things, the hydraulic trench, where we'll have a couple toilet valves sitting in these differentially different depths of holes that are on the same elevation. And we'll keep 12 inches of water in there over a long period of time, typically overnight, and show that we can actually get more water to flow out of the shallow ditch than we can out of the deeper one. And there's only a 12-inch difference. So it's the shallow one mimics our LPP, and the deeper one mimics a shallow conventional system. And the results can be pretty dramatic. And when you got installers standing there looking at it, after I've been talking about it for 2, 3, 4 days, they get the picture all of a sudden. And of course, we emphasize, as folks do nationally, that we want to stay shallow so we can get air into the trench. We stay up in the better soil. We stay away from the rock. We stay away from seasonal saturation. And we've got biological activity up there at that shallow depth, which is also enhancing our ability to treat the effluent. Typical installation in West Virginia for conventional is going to be a serial system. So we'll use what we refer to as crossovers that are designed to allow the first lateral in the series to pond to a specific depth, and then it'll spill over into the pipe that takes it down to the next trench. There's some tricks to that, and we have to make sure installers are doing things correctly. Here's what I consider now the old school design of gravel and perforated pipe, since that's not the most common method anymore, although it was when I started. It was the only thing, except what they might have used 1-foot clay tiles even back in those days. So it's basically 12 inches of stone with a 4-inch pipe situated in there at a 6-inch depth. And here you see that in the cutaway view. And we want to, again, still stay shallow even with this type of system. You see the 36 inches over on the far left. We need, in the modern day, we need 36 inches underneath of that trench to get suitable treatment. This was supposed to have been the chamber slide, but I got my tanks in the wrong place. So here's a septic tank. That's a 2-piece tank or a mid-seam tank, the most common in West Virginia. We do have some leakage along the mid-seam, unfortunately, and you also see some of the reinforcing wire exposed at the surface, and that reinforcing wire, 6x6 inch intervals. You shouldn't be able to see that. That should be in the center of the concrete wall to provide the best support reinforcement. Here's a better looking concrete pour, but it's a top seam tank. No seam along the middle, much preferred, but also not nearly as common as the mid-seam tank in West Virginia. We've tried real hard since I've been here to emphasize tank tightness, and we've made some strides, but we also got a long way to go, I think. Here's the chamber that took over for the gravel. Our people were convinced that in the early days that this was such a superior system that they gave it a 40% reduction over pipe and stone. And we don't know yet whether that was a good idea or not, but everybody loves it because they don't have to haul gravel. They don't have to shovel gravel. There's some other advantages from an operational standpoint. But I mean, we can't say it's a bad system, but we still have the biological material that's finding its way out of the septic tank, now trying to get out of the soil in 40% less distance, less square footage. And so the concept is that we may have clogging of the soil more quickly in that regard. We look hard at the soil for permit purposes, and we have what we refer to as a 6-foot hole. We also have something that's kind of brutal here that you see on the left, the slit trenches in limestone. The limestone ledges run northeast and southwest up in the panhandle, and so we have dug long trenches perpendicular to that to try to figure out where the shallow bedrock is. We're sort of getting out of that and using a little more finesse now instead of tearing everything up so badly, but it's a discussion for another day. Another EPA slide, and sometimes I put their slides in just so my audience knows that I'm not making all this stuff up. In this case, they have the word purification here. And in the old days, we referred to these systems as septic tank disposal systems. We want to change that lingo now to dispersal systems. We're dispersing the effluent out in the shallow soil, trying to get as good and uniform of distribution across the area as we can in order to get the best treatment. And we don't want people to think in terms of disposal as in out of sight, out of mind. You know, we're recycling this water. It's either going to show up in the water well on the property or the neighbor's well or down at the bottom of the hill at the stream bank or possibly deeper in a deeper aquifer, you know, in the aerial groundwater supply, but it doesn't go away. Now, if we've got good soil and uniform distribution, hopefully we've cleaned it up to the point where we're not going to be able to find it again. It's a 6-foot hole because we used to require 4 feet of good soil underneath the trench. And any of you that have done any digging or exploring know that it's hard to find 6 feet of good soil in a lot of West Virginia communities. So we don't always have success, but it's now only 3 feet with a rule change some 20 years ago. But we still dig a 6-foot hole to look for problems. And as we say down here in the lower left, we're looking for seasonal saturation, or also referred to as a seasonal high water table, or excessive rock. I don't say bedrock because our definition is so pitiful that it would excuse too many sites with excessive rock. In other words, if we're not getting treatment in the soil because of the prevalence of rock, then there's too much rock. So we're going to call that a limiting layer and need to work above it in some fashion. When we're looking at soils, we want to see what we see on the left here. It doesn't have to be red, but we want it to be bright and uniform. And then as we move across to the right, you see how it gets more splotchy and more grayish or dull. And that's generally bad. Looking here at a little more close-up view of what we used to call models or modeling, as we say in the lower right, is now referred to as redox features or redoxamorphic features, referencing the reduction and oxidation of iron, which takes place in those wet soils when they're saturated and become stagnant and the oxygen is depleted. The bacteria in the soil then attack the oxides on the iron and somewhat of manganese, and it's released from the soil particle, goes into solution, and it leaves the gray color. That's how the gray is the thing that most people are looking for. The iron depletions is the best term for that. I use this slide a bunch because of the contrast with the surrounding soil, and you'll see it again here in a minute. But if we ignore these colors, this is what we may see, and it's kind of hard. This is an end cap that floated off of a chamber, which you can kind of see on the bottom of the ditch here. Again, that's what the chamber looks like normally. And if you're a sanitarian and you come back to inspect this system and it's, as I say, blowing bubbles like this, that's a bad day because you probably issued the permit. You probably did not notice the coloration that would have indicated that it would be wet at that shallow depth. And that system has no chance in the world of working. here's the distinction I want to make is, and this is again more for practitioners out in the field, but when the backhoe digs the hole, sometimes it can look pretty good until you get in there and poke around a little bit and pick out the side, and then those colors will jump out. Sometimes you don't have to worry about where the rock is, it's everywhere, and that's not good either. This hole actually is too hard to even dig it down to depth. You can sort of see where the rock is more consolidated here, and the backhoe was just bouncing off of it, and so it's a bad situation, particularly if we've got water wells, because any effluent that gets into that kind of rock is going to get zero treatment, and it's going to run straight to the groundwater. Conversely, if we've got tight soils, heavy clays, seasonal wetness, then we get these types of surface failures. And these are some of the worst. The lower left there is more typical of what you're going to see on a residential system anyway. And, you know, when they get this big, we got basically no treatment going on in the soils. Pretty much everything's coming to the surface and just running down the hill. On this site down below here on the lower left, you might imagine that the soil is actually accepting a fair amount of the effluent and moving it off of the site. And that's another thing that's maybe a learning point for folks that don't know, is most of us think that this effluent is going down. And in reality, we have a ton of lateral movement off of the site. And so we have to protect the area downslope from the installation as well as the installation area itself. When you have this situation and you got a small lot with nowhere to go, can't pump it up to a nicer place, then we consider that a potential for what I say here is the last resort option. And that is an HAU, or a little home aeration unit, a small wastewater treatment plant that is designed to treat wastewater from one individual residence or perhaps a small business. And with disinfection, we can then permit that to go to the surface. Now, ideally, we'd have a big old stream like this in the backyard. And oftentimes we do, which is why we don't have any room to do anything else. But a problem that we really fight with these days is finding a suitable place on a lot of these small lots where they envision there's a road ditch beside the road everywhere you go, but that's not the case. And this is one of those facts, one of those sites where if we went to the ditch or the ditch location here, the effluent's going to run out in the road. And then when it finally gets back, as the topography changes, it's going to run onto the neighbor. So this is one of the sketches that are photos that I had to send back to an applicant to show why that's not a decent site. We have a lot of that problem these days. So as far as alternative systems go, if we decide we don't have soil depth to do a conventional septic tank and gravity drain field, we put together this little list here, which basically says with our total soil depth listed in the left-hand column, what can we do? And as you see here, the mound, which sits on top of the ground, we need 24 inches to put a sand mound on a site. That is the least restrictive alternative that we have. So if there's not 24 inches of suitable soil, meaning not excessive rock and not a seasonal water table up within that upper 2 feet, we can do a mound. But if it's shallower than that, we can't do a thing. We don't have an alternative for that. We do not do surface discharges on new construction as a rule. There are some old pre-approved lots that can qualify, that kind of got stuck out there for years. But since 1983, county health departments are charged with approving all residential subdivision lots. And that means that they have a suitable area to install a septic tank and in-ground drain field. And they also have area to replace that drain field in the future at such time when the soil would clog up or the system would be damaged or something like that. So we should not be considering surface discharges on individual lots, subdivision lots. Where there has been some illegal subdivision going on, we automatically try to get a hold of the developer and get them to think in terms of a cluster design to try to make that right, basically. If they're already sold all the property and moved to Florida, then we got trouble. Going down the list here while we're at it, 24 inches to do a sand mound. We can do a drip irrigation system, which I have one picture of here coming up, I think, if it made it in. And that's basically a small diameter tubing that is pressurized and has so-called drip emitters in it. Very similar to backyard irrigation systems, but it's more sophisticated equipment, and it cannot be that type of equipment used for wastewater. It's got to be designed for wastewater. So it can go in as shallow as 6 inches, and it only needs 2 feet underneath of it. And so that means 30 inches total. The LPP, or low pressure pipe system, that I mentioned previously as being one of the most adaptable systems in West Virginia, is the next on the list, and we need 3 feet. Like the drip, it only needs 2 feet of suitable soil underneath of it. That's in the regulation based on the fact that it's pressure dosed, and pressure dose systems get a 1 foot reduction from the 3 feet, standard 3 feet you need for conventional drain field. So the LPP then can go in on a site that has at least 3 feet of soil from the surface down. Elevated fields and shallow fields, by virtue of the fact that the select fill is so hard to get, we just don't see any of those going in West Virginia. Some have been done probably with fill that wouldn't truly meet the specification. But then below that, we get down to just a shallow installation, 18-inch depth for conventional drain field, and then regular conventional installations on down. And of course, the deepest that we go is 36 inches. That's the absolute maximum depth of any type of system in West Virginia. Illegal to go deeper than 36 inches. We have old timers that still have it in their head that deeper is better because we don't want that sewage to come to the surface. But we're fortunately they're fading away at this point in time, hopefully. Here's a mound. This is a whopper over here, taller than most of what you're going to see in West Virginia, but that's one of the best pictures that I have. We'll have a little pressure dosed distribution network up in the top of the mound, and then a minimum of 1 foot, typically 2 feet of sand underneath of that. Then the drip system, here's the drip tubing. It's about 5/8 inch in diameter. You don't really have any scale there, but it truly does drip out of these emitters, which are engineered to meter that water out there very precisely. They're typically rated at somewhere about a half a gallon per hour. And then these will always be on a timer, or more commonly a microprocessor, which will set this up to be various zones of different types of soil or different size distribution networks, and the microprocessor will send effluent out to a smaller zone for 15 or 20 minutes and into a larger zone for 25 or 30 minutes. And this is down in Tennessee. This is a representation of a drip system showing all the components. It's definitely more technical than anything else we have as far as dispersal systems go, because it's got air release valves in order for the water to drive out the air and fill the tubing as quickly as possible. It's got solenoid valves to shut off one zone and switch to another. But these have been around for a while. They've turned out to be pretty robust and long-lived. I did one back in the very early 90s on a shopping center, and unfortunately public sewer came through a couple of years later, although that area needed public sewer bad. Sulphur Springs Road up in Berkeley County, if anybody knows that area. But they work good, and they don't clog. That's the first thing anybody says. They see those little bitty holes and they're like, oh my God, that's going to clog up. And there's a lot of things we could say about it, about why they don't clog, but we don't have time here. And I'm really taking too long as it is, I guess, to get more to the meat of where I need to be. Here's an LPP demonstrating the shallow, narrow trenches that we want to see there. Most commonly, that's going to be 12 inches wide, 12 inches deep, and on very precise contours, because we're going to want to use that. That's an emphasis that we really hammer on conventional systems as well, to stay on the contour, and of course with a level trench bottom, to maximize good distribution, but also the use of that very best soil at the surface. Here's a depiction showing some of our communities that have the well-known problems in West Virginia. We got straight pipes here. I use this slide a good bit because it emphasizes how much that we have accepted the fact that we're stuck with these types of systems or non-system in locations, because here we have flood damage. Corps of Engineers comes through and reestablishes the creek banks and puts these gabion baskets in here and just goes ahead and extends the pipes while they're at it. So, you know, it's kind of hard to, when somebody's been wiped out by a flood or nearly so, it's kind of hard at that point to say, oh, by the way, you got to spend another $15,000 on a treatment plant. Although we've probably missed the boat a few times in getting some community pipes in the ground when the areas have been tore up by floods, but that's another story too. This is an infamous site down in McDowell County. It was in the study report that was done when the McDowell sewage study was done, I don't know, 20 years ago now. Doesn't seem that long to me, but I saw this picture and I'm like, I got to have that picture, because that's, seen a lot of pipes, but that's the worst one ever. So talking about cluster designs, my experience for the most part, unfortunately, is with not with this is where people actually have money to pay for it. You know, we haven't had to whip up the interest in the community and you know, get that buy-in. That's always the first major hurdle on these projects, because, you know, a lot of folks are concerned about not having suitable sewage facilities, and the fact that the kids are out there potentially playing in the stream, or, you know, even if it's a surface failure on a regular septic tank system, you know, there's exposure to contamination there. but yet they still don't want to pay the sewer bill. And so, you know, we need to whip up that community support and emphasize all the advantages that come with, you know, cleaning things up and getting a suitable sewer in there. But this is a case where it was rental property, and, you know, somebody says, hey, I know I got big problems here. This was all wet soils down here. You can see the old system here is all green. This one here was the same way, and it was running down the hill and hitting this little drainage way here. This is a apartment building over here, and you can see all the green grass down here. And then when you get the big green downstream or downslope from that, you know that it's probably failing during, at least during the wet times. So we had these mobile homes and the apartment building, blowouts all over the place. And we came back and put in basically new septic tanks, brought them to a central pump location, and just went with conventional drain field out here. This is Back Creek, again in Berkeley County, and just put in a large drain field that's pump dosed, which the pump by itself provides a lot of advantages. Even if we use conventional drain field afterwards, conventional gravity drain field, we can separate that flow so much easier than you can the gravity flow out of a septic tank. And you also, regulatorily, you can run longer lines. We have a limit on lateral length in West Virginia with conventional gravity systems of 100 feet. Well, now we can go 200 feet if the area calls for it. And here it did. You know, we have to stay away from the creek bank, but we still got pretty good ground out here that is well drained. Not, the wetness was back here closer to the upland site, and all this starts to go uphill from just outside of the picture. So that water moves down slope, and then it creates the shallow wetness that we had to fight, or they had to fight up here previously. So this was an easy fix, and you really want to find those kinds of areas, and you don't do it very often. This was a brand new site where we have 33 lots, all on septic tanks and variable grade sewer. You know, that starts the discussion on how we save money on the collection lines. If we use septic tanks and keep the solids back at the structure where they're being generated, then the sewer doesn't have to be large diameter, number one, and it doesn't have to be straight as a laser beam from manhole to manhole as it does for conventional sewer. So this was new construction. I was working with a company that was promoting constructed wetlands back at the time. They disbanded before this system went in, but a couple engineers in my group designed it, and then I did construction management. I knew the people that owned this property. I actually tried to buy it because you can't really tell, but it's long and flat. And I wanted to do a little fly-in subdivision there, and which was something that I had thought hard about way back in the day. I probably should have done it, because what seemed like a lot of money to me at the time wasn't all that much, and I could have got that property reasonably, but that's another story also. But they just rolled with the concept of variable grade sewer, which we were promoting. A wetland system cannot handle the solids. It's effluent only. So we keep the solids in the septic tank. We actually put an extra tank down here right near the wetland to catch anything that might escape from those tanks if somebody doesn't maintain theirs properly, although obviously we're going to put them on a maintenance regimen, and that's another part of this conversation when we talk about these more inexpensive sewers and using septic tanks. It's one of the reasons that these don't proliferate as they should, because PSDs and municipalities that are operating sewage treatment plants in the area who we want to maintain the systems don't want to fool with septic tanks. And, you know, it's a foreign concept to them too, to maintain small diameter lines. Likewise, and I have slides that speak to this coming up here if we make it. I don't know. It's 3:20. I don't know where I'm at on my time. Started at 1:30 to 2:15. Is that how it goes?
2:30 to 3:15. And of course, we didn't start you right at 2:30, but if you could wrap up pretty soon, that would be
All right. Yeah.
fit in with the program.
It's an educational thing that we're still fighting 20 some years later, trying to get engineers to do more design work with alternative technologies. Here's one that a lot of you are probably familiar with down at McDowell County, Ashland, where we put in septic tanks along this. This is a very simple layout here because the town doesn't sprawl very much. There's the company store down here and a couple more residences around the corner. Constructed wetlands up on the old bench on top of the ridge, where I guess the coal mines had been previously. And so we're pumping, which is the one downside of this installation is these pumps are working pretty hard and they've had some issues with keeping the pumps going. The wetlands provide treatment, and then we go back into the soil. We have an LPP down here on the side slope. So we gravity flow back down and then use siphons to dose the low pressure system. I guess it's around in here somewhere, maybe, I don't know, in that neck of the woods. Getting back to the EPA report, and some follow-up stuff. I guess this is probably after the big response to Congress. But they recognize here that the engineers are not making as much money because they're basically getting, or oftentimes getting paid a percentage of what the design installation costs. And then they don't know decentralized because they didn't learn that stuff in school, at least back in the day. That's getting a little better, but we don't think it's really gaining the traction that it needs. Regulations, I don't think that that's really a problem in West Virginia because we recognize the need for this kind of thing. We got to get some cheaper alternatives out there, or we're just not going to get sewer into some of these areas. This gets more specific about the financial reward for using centralized. The perception, again, a lot of people look down their nose at septic tanks, and I have to agree, we've got too many leaking tanks. But I try to convince PSDs that, you know, they need to do some capacity building and train some people to, studies would indicate that solids management with septic tanks is more efficient than it is at the main treatment plant. They fight those solids at the treatment plant, spend a ton of money drying them out, hauling them away, spreading them, whatever they do. Whereas anaerobic treatment in a septic tank, if everything's done right and we don't pump unless we have to, is very, very efficient. And we've actually seen that already. We've seen that. High Point, I want to mention this one time. Recirc sand filter for 44 lots. This was done right before I left Berkeley County. It's 25-ish years old now. It was only supposed to operate for a couple years at the most before public sewer took it offline. We only built the first half of it with that in mind, but they sold that subdivision out and then they hit a bunch of rock and they could not get sewer there too. So to this day, the Berkeley County PSSD operates this system. And I built that thing for 44 lots contracting out some of the stuff, but I did a lot of the handwork and some of the excavation myself. But I built it for like $150,000. And we're doing systems now where they're costing more than $50,000 a residence, with alternative types of treatment and typically conventional sewer. Now, that did not include the collection lines. That's just the sand filter itself. Here's another one they did 10 years later, using my basic concept. Basically, it's a so-called pond design, as you see here. This is half of that system at High Point. You basically put the under drains underneath the sand right on top of the liner and then build right on top of that. Much cheaper. Up at our training center, we're trying to build things with the idea that here's how you could do it in a modular fashion. This is the sand filter that you just saw. And basically that would treat, if you see down here in the lower left, 4.8 residences. That's it. I don't have my on-site kitty anymore, but she's still in my library here. So she ended up being the question. It's supposed to say questions right there, but I didn't get that done. Sorry, I run over.
It's all right. It's hard to do. We'd like to move right to Barry's talk. And hopefully there will be some room for questions at the very end.
I think Rick needs to take his down. Correct?
Oh, yeah. Sorry. I got to
That's
do
okay.
that, don't I? Stop share, right?
Yeah.
Yep.
Okay.
Yeah, Martin, you want me to introduce Barry? Yeah, okay.
Please.
All right. So our next presenter is Barry Milam from the former manager of the Crab Orchard MacArthur Public Service District in Western Raleigh County. So we heard public service districts mentioned in Rick's presentation. So we are going to now hear about perspectives on non-point source bacteria pollution from the former PSD manager. So thank you, Barry. And yeah, whenever you're ready,
Thank you.
take it away.
Well, get it going here.
Here we go.
My computer's old and slow. Sorry.
Okay.
Yeah. Yeah, my son told me that 10 years ago. So yeah, I think I'm now screen sharing. All
Yep.
right.
We're ready. We can see your presentation.
Yeah, my name is Barry Milam, and I was general manager of the Crab Orchard MacArthur PSD for about 27 years. And I had the pleasure of working with 3 different watershed groups. Well, I don't know why I'm not being able to move on.
And mine wouldn't advance at first either. I don't really know what changed unless somebody else switched the controls over.
Share. Okay. Now I'm there. Okay. The territory was in southwestern Raleigh County, and to the district area included the Guyandotte watershed in the south of the district. The Coal River watershed was in the west of the district, and the New River was in the east. So I've worked with, started working with the Upper Guyandotte watershed group first, and then the or the Trap Hill watershed group first, and then the Upper Guyandotte watershed, and then went on to Piney Creek from there. The first group, the Trap Hill group, I first met with Trap Hill Lions Club, and then they started the Trap Hill Watershed Association to be able to try to get some grants. And then the first project was to get funding to clear debris from the Marsh Fork River or creek after the 2000 floods. And we included a sewer study when we were going after that money for the upper Marsh Fork watershed area. The watershed group was able to get letters signed, and this was a really good effort on their part, by 400 plus people. And we sent those letters to all the local, state, and federal representatives. So everybody in the chain got 400 plus letters. And from that, I got quite a few phone calls since the territory was given to us, and about trying to do something down there. We were able to get a legislative grant from Speaker Kiss that was in office at the time to do both the stream cleaning and a sewer study for the stream. But a little advice, don't always count on receiving the money, even if it's been promised. It took 3 years of getting that money. Twice the county used it for other purposes because the funding had to go through the county. Then we were able, with the Watershed Association, Lions Club, and the Crab Orchard MacArthur PSD, we were able to get a $700,000 grant from the U.S. Corps of Engineers through Representative Ray Hall. And the PSD took out a $250,000 loan from West Virginia DEP SRF for the design of a sewer system for the communities of Fairdale and Glen Daniels, Surveyor, Lester, and Glen White, and also Eccles and Harper. Unfortunately, Katrina hit New Orleans, and the Corps of Engineers money wasn't available for about 3 years there. But we did get the design done. And the first project we were able to do from that design was the town of Leicester and community of Glen White. It was built, but the Glen Daniels Fairdale system was designed, but it has not been built yet. The only funding available to the area, because of a lot of coal miners live down there. So the median household income was up quite a bit. And all we could get was SRF loans. And that was going to double our rates pretty much. And so, they kept phasing the project down to where phase 1A was only going to be the sewer plant, and it was going to be cut back to a smaller size, plus about 300 customers. Of those 300 customers, 100 of them we already served with a package plant, and we already served the school. So there was really not much income from the area that was available to pay the loans with. So anyway, the board decided that it just wasn't feasible to continue because of the rate increase, and it was going to tie up all our loans for another 40 years. The existing loans, they were going to do a wrap loan. But it's kind of disheartening to have that happen. And it was an area that had, anywhere from 8,000 to 20,000 fecal counts in the stream because it being the area originally was called the Marshes. And so it's a really wet area down there. And I mean, you dig a hole and it fills up full of water. I've seen septic tanks float up out of the ground right after being installed because they didn't fill them full of water down there. That's happened several times just driving by and noticing. We actually operate, the Crab Orchard PSD operates several package plants down in that area that we were asked to take over from homeowners associations and the schools. But one of the things I think that hurt the project going forward was the fact that both the Lions Club and the Watershed Association, it kind of disbanded. And so we have no local voice down there from the people actually pushing the project. I know I received a few calls when we first started because we were starting to get easements down there, and people were kind of concerned about what was going on and how much it was going to cost and that kind of stuff. But anyway, right now, or we did sewer Lester and Glen White off of that study, which is the very headwaters of the Marsh Fork. And we were able, the PSD was able to acquire through the county commission and the governor's office a AML grant for the Eccles Harper area, which is the other main stem or the other tributary of the Marsh Fork. So that's good. That'll take four communities off. That still leaves Surveyor and Glen Daniels and Fairdale. But anyway, projects are hard to come by, and they're pretty complicated to get in and do. I know that years ago we counted how many hoops we had to jump through to do a project, and at that time I think it was 43 different hoops that we had to jump through, from historical to endangered species, just different things. And there's a weed down there called Virginia spirea that we found several of. So that kind of, we had to go back and redesign some of the system, even though it would be easy to do some type of underground piping to get underneath it, whether it's ramming it or other types of ways to get piped through the ground without disturbing the soil on the surface. But they wanted us to not disturb the area at all. And then after that, I worked with the Upper Guyandotte Watershed Association and the Watershed Group, and a community group called the Winding Gulf Restoration Organization, worked together to try to clean the streams and do some work down there. And it included not only Winding Gulf, but the town of Rodale that was on the Stone Coal tributary, and the town of Amigo that was on the Devil's Fork stream. And they make up the headwaters of the Guyandotte. Matter of fact, the Guyandotte starts where those three streams come in together. And then worked with the Canaan Valley Institute, and they did a stream study, valuation of the cost to clean up the stream. And this was, back in early 2000s. But from that, we were able to get funding for the community of Helen. We were able to get study funding through the Watershed Association. And then we received design funding from the DEP. And finally, we got a 1.25 million, $1,250,000 small cities block grant and a $750,000 SRF loan to build a system in Helen. And this removed about forgot about my slides. There's the upper guy dot. And the areas we were working in, if you're looking at the map, is the bottom left corner of that's Trap Hill, sorry. And that's the system that we were designing for the Trap Hill system down there. And like I said, it just has not been done yet. But that phase 1 was broken down into phase 1A and phase 1B, and all the little hollows that you see there and going down to Liberty High School and down to Surveyor was cut off. So the only thing we were getting was the main road. And it was just going to raise the rates to where they were pretty well maximum rates. And we didn't see a way to do the rest of the project at that point in time. Need to get an AML grant down there because there's some old mining in that area. And here's the Upper Guyandot watershed. Winding Gulf Stream, as you can see, top right-hand corner was the one that we were working on with the town of Helen. Rodale sits at the very bottom of Stone Cold Creek, and then Amigo sits at the very bottom of Devil's Fork. And one of the things that we did was the community of Slab Fork had a sewer system and it was failing big time, and we were able to and the plant had rusted through. The bottom of it was all rusted out and everything. So we're able to get a old sewer plant from an extension that Shady Springs PSD did that served a hotel up near Winter Place. So when we got that, we put those concrete tanks in at Slab Fork and did away with the old plant. So we pretty much cleaned up all of the very upper part of Slab Fork Creek. There's still a little town of Hotchkiss down there in Raleigh County, but the rest of it's in Wyoming County, so it was out of our district. Anyway, we now I think I've got a picture of straight pipes. Yep, there's a picture of straight pipes. 6 of them, and there was 100 of them in the community of Helen. And it was bad. There was one place where Berry Branch came in to the Winding Gulf, and under the bridge, under the railroad or under the road bridge, the water just swirled, and the fecal was about 6 or 8 inches deep there in that swirl. It was, and a lot of the homes, they just went to a ditch, and then the ditch fed into the stream. And the next project we did was one that Rick came up and tested the soil for, the little town of Uri that at the time had 14 homes in it, that now has 7 in that amount of time. The homes have either burned or been torn down. So what we did there was DEP called the PSD, and wanted to know what we could do about it, because the 12 of the houses were on one pipe that ran down the road and came out into the creek. So that if you've got more than one house, my understanding is if it's more than one house on a pipe, then it becomes a DEP issue, because falls under their jurisdiction instead of the health department. So they called, wanted to know what we could do about it. And we had extended lines, and then also the town of Sophie had extended lines up to the Independence grade schools. And we had picked up Fairdale School and Leicester School, their old plants, and taken them out of the ground and filled in the holes. And so we had some plants. We had like 4 or 5 plants down there. And we reconditioned a plant for Uri, sandblasted it, recoated it. And our guys know how to run package plants. And we have no place at the plant to bring in septage. So we were trying to go with the package plant into a small diameter weep system that we purchased from American Manufacturing, which has the little emitters, and it's about a 5/8 inch. And it's a little bit complicated. It has some electronics there, but we've been operating it since 2011 maybe, and it has not burped yet. I mean, there has not been a hiccup on that system at all. The guy that runs it is down there a couple of times a week. They do keep some of the grass cut, or the brush cut, in the area where the wheat fields are. But it has worked really well. And it was myself and the DEP folks, Kathy Emery. I guess we just wanted to put a system in like that to see if we could, if it would be something that we could use in the southern part of the state in the headwater streams. And it's, like I said, it's worked out well. We do have the Rodale project down there that's on Stone Coal. Oh, the total cost of doing that system down there, even though there was no cost for the package plant, was about $500,000. So that was for 14 homes at the time. That's now down to 7. So what happens when you keep losing customers is the systems get hard to maintain. You have to have a certain food to mass ratio coming in. You got to keep the bugs happy. You got to keep them fed. You got to keep the temperature correct, the oxygen levels up, to be able to get good effluent. And then, like I said, the town of Rodale, which is on the Stone Coal stream, it's been pretty interesting to go through that process. The town was incorporated. At the time, it was one of 22 incorporated towns without a sewer system. And the DEP, I don't want to say hit list, but they just had a list of towns that was incorporated that they wanted sewer systems in. And Leicester was one of them, which we picked up with the system at on the Marsh Fork. But Rodale, and we held meetings down there. I was at several city council meetings and everything, and DEP was along, and Region 1 Planning and Development was there. And there was a lot of pushback to having a system down there. One of the things that was going on down there at the time was the water came out of an old mines, and it wasn't treated. It just went to the homes basically untreated out of that mines, which was just below the town. And when the floods got up, it filled up full of water, and I'm sure it filled up full of sewer. But they paid $10 a month for their water bill, flat rate. And some of them didn't even pay that. So when we came in and said, you know, your rate's going to be $50 a month, and at the time they were looking at getting their water transferred over to Raleigh County PSD, which is the water utility close to there. The people were really not wanting to pay a water and sewer bill that was going to be around $80, $90. So they were not wanting to do that. So they actually voted to unincorporate the town, I guess, to get off that list from DEP. But we'd already started the process, so we were trying to go through with it. But to put in a centralized system down there, we were looking at $100,000 per house. Those houses are worth about $30,000 to $40,000 down there. It's an old coal camp that kind of got well established by the people being able to buy their lots. The coal company that was there decided to sell the lots off to the people. Recently, and I believe Rick was included in this federal group, federally funded study that had two places in West Virginia. I think Coalwood was one of them, and Rodale was the other one. It was a group called Closing America's Wastewater Access Gap. And it included a lot of federal folks and engineering group that had the contract. Their study is showing that kind of a centralized system was going to be about $150,000 per house. A decentralized system was going to be about the same price, to have about 5 or 6 package plants. There was going to be close to the same price. I tried to get the PSD involved in home aeration units when the local guy that did them pulled out and nobody was taking care of them. And I thought, you know, we could get into that business as long as we weren't getting septage. We actually have a tank that we have on a trailer that we pumped the sludge out of the 10 package plants that we ran and brought it and put it into the system in different places, and then it was pumped down to the main plant, and then the sludge is taken care of from there. It kind of breaks the DEP rules about sludge, but because they wanted everything accounted for, but it still went through our plant and was placed on a farm from there. But the I felt like that we could do individuals or grouped home aeration units. There's some out there that I know there's an SBR home aeration unit that's used quite a bit in Florida that seemed to be kind of ideal because it wasn't septic, it was aerated. So it was an aeration type system. We could go pump them and do the same thing we do to our package plants, take it to the main plant or the main system and put it in. And then I wanted to do like a UV disinfection. Part of the problem you run into in these coal camps is the fuse boxes that they have in their house, or the breaker boxes, are really old, and you can't use their electrical system to run anything. So it was going to be us installing power and doing drops to several systems to try to do this. Unfortunately, the DEP permitting people don't like to see clusters of home aeration units. So they kind of nixed that idea. But we were looking, instead of $12 million, we were looking at about $3 million to do that work. One of the interesting things that I learned out of that study was that the DEP doesn't consider straight piping as being a pollutant or anything in the stream. And that was my understanding anyway. So the plants that we were going to put in was new pollution to the stream. Instead of, being able to take out 99% of the pollutants in all the fecal, that wasn't going to work.
Barry?
Yeah,
We are running
we're
out
getting
of time.
close.
Yeah.
Okay. Oh,
And
yeah, we are.
so there are no questions in the question box, but we would like to open it up in case anybody would like to put a question in the question box or speak one out loud. I guess I'll start. I've seen advertisements for effluent treatment systems where they save a lot of money by putting in skinny pipes rather than full sewage pipes. And they say that if you do that, you can just run these skinny pipes along the shape of the land. You don't have to put them through the hillside on a grade. Is that just advertising, or is there something to that?
Well, do you say skinny pipes?
Well,
Small diameter
small diameter, not.
is more the terminology, and
Thank
that's
you.
what I was alluding to when I said septic tanks and variable grade sewer. So it's following the basic topography. Sometimes there's pumps involved, and sometimes it is purely gravity if the the landscape, the topography allows for it. There's tons of so-called Environment 1, E1 system or E1 units in systems here around Charleston, subdivisions that are fairly modern, and they just went and put those in from the get-go. I have not looked at the cost factors for those versus what we generally consider at first glance is just a regular septic tank with an effluent pump in there. But the PSDs would be happier not having to go after the solids back at the residence. And so the E1s are grinder pumps, and they move solids as well. But as I mentioned, there's a lot of studies that would indicate that small diameter sewer is a whole bunch cheaper than conventional large pipe, so-called large pipe gravity sewer.
Martin, were you talking about the seepage field or the collection system?
Well, so the advertising I've seen talks about everybody in the subdevelopment has a septic tank with a pump in it. They pump the effluent up to a fairly simple effluent treatment, and then they can either send that treated effluent to a leach system or, well, probably to a leach system.
Yeah, I
Is
mean,
there-
it's definitely a thing, and uh it could go both ways. You could have less sophisticated treatment going then to a drain field soil absorption system, or full tertiary treatment with disinfection and going to the surface. Just depending on what the circumstances are. Everybody's always happier, both health and DEP, if we can find that sweet spot to do a mass drain field, uh, even for conventional sewer, but most likely for at least partially treated effluent. Um, but in southern West Virginia, those are hard to find, where you've got suitable soil over a large enough area.
Yeah, we looked down at Amigo at a very nice flat bottom area, and it turned out that the old mine ponds were in there. And when they closed the mines down, they took barrels of different liquids, like the oil that the shop used, and probably PCBs and everything else, dumped them in the pond and then covered it all up. So when we did a little bit of soil testing in there, we decided that um, that wasn't a good field to use for effluent pumping,
Yeah, it's a
although it
shame.
would have been ideal to place to do that. Good thing that I talked to one of the neighbors.
Yeah.
Well, thank you both.
Yeah.
So- oh,
Are
there
there-
is something in the Q&A.
Oh, there are. Yeah. Barry, would you mind exiting the share screen whenever you get a chance?
Yep, I will do that right now.
And then the question that we have in the Q&A here is anyone doing composting toilets plus gray water?
Um, there's been a few. It's most people find out that composting toilets aren't as odor free and maintenance free as they might have heard or read somewhere. Uh, I don't have a lot of direct experience with it, but I do have one kind of sad story where I did a system for the gray water. Uh, I don't remember the name of the subdivision. It's an old lakefront community not too far from Morgantown. Um, and the homeowners association was pushing for everybody to clean up their issues with wastewater. And so they were spending money and doing some innovative stuff there. I actually did two systems there, but the funny part was when I was talking to the husband and wife about the proposal, and they didn't have a lot of room to do a gray water system. So we did like a little mini constructed wetland, and then it went over to an Elgin system, which is another system that's designed to have a pretty big reduction in square footage based on its treatment capabilities. But the wife kind of said, I got just got one more question for you. And the husband just immediately looked up and walked away. Like, I don't want to hear this. And she said, what if we don't want to use the composting toilet at some point, if we want to go back to a water carried system? And, they basically didn't have options. Their space was so limited. Plus, we're not putting in a full blown septic tank, which is the typical gray water system in West Virginia. Our regulations are a little bit antiquated in that regard. A gray water system, particularly if someone is hands on enough to maintain it, doesn't need to be that big, and it's better if it doesn't turn septic. And of course, 1,000-gallon tank, which is our minimum size, is going to be septic every time. So the word that came back to me years later that they did do something to convert back to a water carried system, but it had to be a treatment plant. I don't think they were allowing discharges to the lakes. I don't know. Never did find out exactly what they did, but they didn't stick with the composting toilet. The other interesting article is still available online. Was in the Small Flows newsletter years ago about a lakefront community up in New York State. And it had a long, convoluted name, but I understand it was pronounced Skinny Atlas, although it didn't look like it. It was kind of more like Krzyzewski kind of thing, if anybody gets that joke. But those folks, they had a service where a boat would come around. They were basically using buckets inside the home for their toilets. And some poor guy came around every week or so and picked up these buckets and gave them a clean bucket and took the full bucket to wherever the disposal was. And these folks that were using buckets still did not like the composting toilets that they retrofitted to, which was a kind of a sad commentary on composting toilets at the time. Again, this is 20 plus years ago, and most all of them have fans now that assist with the exhaust. Even if there's no power, they'll have what do we call it? The ultraviolet, or how do we make electricity from the sun?
Solar?
What's the word?
Photovoltaic panels.
Say again?
Photovoltaic panels.
Yeah, they've got some method to keep power there and keep the odors out. So hopefully they've got beyond that point. But I guess the short answer to the question is there's not much of it happening, but I get a question about it every now and then. It's certainly something we can permit, but the gray water system is not a simple and small installation. That's probably the more direct answer.
All right, thank you, Rick. Any last questions? I know we're a little bit over. Not seeing any hands, not seeing any typing going on the Q&A here. So I end our webinar for today and give you a little information about our last webinar of this series. So this was our fourth one out of the 5 webinar series. So the last webinar is going to be next Thursday, March 7th, also at 2:30 p.m. And we'll be hearing from Tim Craddock, the Nonpoint Source Pollution Program Coordinator at West Virginia DEP. And he'll be talking about rules and tools in the Nonpoint Source Program. And we'll also hear from Kathy Emery, the Chief Engineer for DEP's Clean Water State Revolving Fund Program. And she's going to be talking to us about basically giving a brief overview of the introduction to the Clean Water State Revolving Fund and its partners and how it works. So if you aren't already registered for next week's session, I encourage you to register. Martin will put the link to register for that last webinar in the chat. And then just a quick plug for our newsletter, the WaterNet. This is the Watershed Network's quarterly newsletter. Martin will put a link to sign up for that newsletter in the chat too. It just keeps you up to date on all the goings on in the Watershed Network. And we'll also include a link to all the recordings from this webinar series in our next newsletter, which will come out sometime next month. And then lastly, if there's any other topics that you would like the Watershed Network to have trainings for, you can send us those ideas. And so Martin will pop my email in the chat so you can send me an email with your topic training ideas. So with that being said, I'll just say one last thanks to Barry and Rick. Thank you so much for the very informative presentations today. We appreciate your time, and thank you everybody who was able to join us, and we hope to see you next week.